similar way. So there are two inclined planes are there. So this is alpha, this is beta. So the planes are inclined at an angle, alpha and beta. I'll project with a speed at a distance a from one of the inclined. So from point P, I'm projecting it. So it will go and strike the other plane normally. Like yesterday's problem, no? The same conditions at t equals 0, I'll project it. So I'm asking, you know, what is the time of flight? Yesterday's condition only. So I'll project. So I'll write some conditions here. Its stone is projected at point P from one of inclined plane, and it strike the other inclined plane normally at Q. Find the time of flight where OP is equal to A. Given is yesterday, I think we have discussed that I'm asking you to apply it carefully here. Yesterday, what was that inclined planes? Alpha and beta, they were perpendicular. They need not be perpendicular here because he has not given alpha, beta. You need not assume them to be perpendicular. So some angle you can assume where that angle is need not be equal to 90 degree. Proceed in the same way. Proceed in the same ways earlier what we did. These two planes, the angle between the planes need not be equal to 90 degrees. So in that case, you can't say that velocity of projection is along the other incline, along OQ. Is that okay, fine? Same diagram. So some of you are asking question like same diagram. I'll redraw it so that it'll be easy for you. Same diagram. You can continue your work. I'll make a little bit easy for you so that alpha, this is beta. I'm projecting normal to it. I think now it's very clear for you, and it will strike at point Q. First, we'll go for trajectory. The trajectory will be okay. You can see clearly, though it is projected normal to it, but it need not be parallel to the other incline. Okay, here we have projected with a certain speed that is also not given, and it will strike the other incline normally here also. So you can, what you can do is you can proceed like this. So let this be the so let this be the point PQ. Okay, let me take this is N. Let me draw one line PN, which will be normal to the other incline. So this, if you want, you can give the name like to the incline OB. Okay, look at the, let the speed of projection be U. So we'll resolve this. So you get one component will be, what can be this? If this is phi 90, this will be 90 minus phi. Try to see the mathematics. It'll be very easy for you once you can get this. If this is 90 minus phi, this should be the phi. So what is this component now? U sine phi, shall I write? What about the other component? The other component will be U cos phi. U sine phi will be parallel to the inclined plane OB. I resolved it. And it will strike normally, no? So here you write few. It doesn't appear. So I just made a diagram like that. U sine phi will be parallel to incline OB. U cos phi will be perpendicular to incline OB. Okay, fine. These are the things. So now what you're going to do, you're going to resolve this G. So resolve the G now. So this will be how much? G sine beta. This will be G cos beta. G sine beta, and that will be G cos beta. Write the equation now. First, perpendicular to incline OB. Perpendicular to OB. And I'm proceeding with this. Perpendicular to OB. What is the final velocity? It will strike normally here, no? It will strike normally at Q. So therefore, what will happen to U sine phi by the time when it moves from P to Q? Will become 0. It is striking normally. So 0 is equal to U sine phi minus G sine beta time of flight. Try to see that. Why do the U sine phi will decrease? Why do that initial velocity U sine phi will decrease? Because of retardation G sine beta. V equal to U minus AT formula I'm applying. So when it strikes the inclined plane OB, it will strike normally at Q. So therefore, what happened to the component along OB? Decreases, becomes 0. Okay, there's a one equation. Okay, now after this, can we write this distance Pn? What can be the distance Pn? Sine phi equal to Pn by A, and the value A is given. So let me write one mathematics. Sine phi is equal to Pn by Po. So what is Pn is equal to Po sine phi, which is equal to A sine phi. Come for this. Phi is what I assume not given. Phi is what assumed here. What is phi will be? Alpha plus beta plus phi is equal to pi, no? It's assumed one, it has to be eliminated again back. What is Pn? Shall we say when the projectile moves from P to Q, the Pn will become range. Will I agree? As it moves from P to Q, the Pn will become range, no? So what is the displacement perpendicular to incline OB equal to Pn? And what it makes, the G cos beta will accelerate, and what is the initial velocity? U cos phi. So shall I write S equal to ut plus at square? So perpendicular to, oh wait, this is parallel to OB. Okay, next you write perpendicular to OB. Write one more equation. Distance Pn is equal to U cos phi theta plus G cos beta T squared by 2. Try to see all the things I think in the diagram, and I'll make it visible. Writing this equation 1, 2 is what the concept. As it moves from P to Q, what is the displacement perpendicular to incline OB is equal to Pn. So Pn equal to U cos phi T plus G cos beta T squared by 2. So what is further Pn? Pn is equal to A sin phi. So A.
Sir,
Yes, ma'am.
from equation 1 only can't we say the time of flight, sir?
You don't know, no? It's unknown thing, no? I'll write it. U is assumed. Phi is assumed. I should replace them, no?
Sir, it is G sin beta T by 2, no, sir. In first equation.
This one, huh? G sin G cos beta, no? It should be.
First equation, sir.
First equation G sin beta.
G sin beta T by 2.
V is equal to U minus dt, correct, sir?
G sin beta is a retardation, and U sin phi is the velocity. Okay.
Yes.
Fine. Okay. Now solving this, because say you can ask what's our equation 1. In equation 1, what when U is unknown, I should eliminate U. Phi, okay, I'll get it. Pi minus alpha plus beta, phi I'll get from there. But U, I don't know. So therefore, I'll write one more equation. I'll eliminate U from here. I'll solve for T. I'll get the required answer. You can also get the value of U also. I'll write down the answer. You later on clarify it. 2a sine square alpha plus beta G Okay, this is the expression for the time of flight. Okay, it's all about again equations of motion. So what you should do, you should have a just basic idea of that. What is the trajectory? How the trajectory, how it makes. Then everything what's happening, you have to convert that parallel to incline, perpendicular to incline. Then apply equations of motion. I think whatever the type of numerical come, keep this in mind. That's all. So even if I discuss under numerical, the idea will be same. By this time you might have seen your teacher is not doing anything very big. Just is applying equations of motion.
Sir, we have a first equation now, sir. G
Yeah.
sin beta t is equal to u sin phi. Where did we use that, sir?
I'm not getting.
Where did we use that, sir?
Where we use data?
Yes, sir.
What do you mean by that? Where do you use that?
Like, did we find it to just generalize the equation, or is there any need for that finding that equation, sir?
V equal to U plus AT formula.
Okay, sir.
V equal to U plus AT formula. Okay.
Okay, sir. Yes, sir. Thank you.
Completed. I'll go for in the next one.
Yes, sir. Sir,
Ah,
didn't you give you, sir?
U is not given. No.
Okay, sir.
I wrote there assumed. U is assumed.
I didn't see it, sir.
Okay. Fine. No problem. I'll write down the equation. A projectile is fired with velocity u at an angle theta so as to strike a point on an inclined plane. We have to find out, you write here, inclined plane, the angle theta is so adjusted in such a way that the projectile can strike the inclined plane in minimum time. Read once. Find the minimum time. I'll give the diagram. This is the inclined plane. This is given. This is the angle of inclination. It has to strike some. There's an inclined plane. At t equals 0, I'll project. It is projected at a distance a from one end of the inclined plane. So how the value of the theta is so adjusted that it will strike the inclined plane in minimum time. Okay, what all given thing? U, theta, alpha, and the distance c. Okay, read the question and try to get the trajectory first and see what you can do after this. You have to be a little bit, first get the diagram. It's telling it will strike inclined plane. So how it will strike all, so that depends on the answer. But it has to strike the inclined plane in minimum time. If there's no inclined plane, what will happen to it? It will move in a parabolic path. So you can proceed now in this way. The same diagram. Let me continue here. So I'm projecting from here. Let me take that point of projection as origin. Here I'm going to project with a speed u. Will it go straight? Will it just move vertically? No. It's going to describe, if there is no inclined plane, what will happen? It will describe parabolic path, no? So do like this. There's a path of it. So here it will come in. Strike with the velocity. So from P, what happened? We projected. From O, you can take this out, you know. It's somewhere at point P, it will strike it. This is a path. At t equals 0, I projected. So at time t, it will be available here. This time should be minimum. For that, the theta will be adjusted. I think you can get, student, if you can get this now, okay, try something you can do here. So now what is the distance it is given? So let it strike the inclined plane at point coordinates x comma y. So therefore this will be y, this distance will be x here. So what is this distance will be? A minus x, because the distance is given a. Get ready with all this. First get all these things. This is a trajectory path. Alpha, no, this is angle of inclination given alpha. Okay, all of you. So this much I think anybody can, after getting the, after reading question, no, you have to proceed here till here. Okay, now this is inclined plane, this is ground. Okay, let's write equation. What is vertical component of initial velocity? U sine theta. So the first equation will be y equal to u sine theta t minus gt square. Along x-axis, u cos theta into t. Similar to oblique projectile, it is. Then what is the d is equal to, no? This a minus x is there, no? So let me write in another form. So let me write this. Tan alpha is equal to y by x dash, I'll write it. So what is x dash is equal to y cot alpha. So therefore what is a is equal to? A equal to x plus x dash. Okay, what all given things for us? U, theta and a are given. So what are the things what we assumed is x, y and theta. So what shall I do? I'll substitute 1 and 2 in the equation 3. then x and y will get eliminated. Then what do we end up? We end up with only time and theta. Time and theta. Now I'll differentiate that equation to get the required answer. I think this equation 1, 2, 3 is the core idea. Once you get this, rest of everything you can manage.
Hi, sir.
Okay, now okay, anybody? What to do after this? Substitute 2, 192, 192 in 3. A equal to, what is x? X is equal to u sine theta t minus gt square by 2. X is only u cos theta, no? Y is u sine theta t minus into cot alpha. What shall we do here?
Differentiation.
The time should be minimum, no? So I should differentiate this equation with respect to dt by d theta. Theta is here, you can see that one. So what I should do, I should differentiate with respect to time. Okay, differentiate.
So first we can simplify the equation.
Differentiate t with respect to theta. Okay, then we'll proceed. So this will be 0. Differentiation of constant should be 0. Okay, fine. So I'll proceed like this now. So this is you. Differentiation of cos theta minus, this will be sine theta d theta t, this is, plus u cos theta dt. Then similarly the same thing, u differentiation of sine theta cos theta d theta t plus u sine theta d theta.
Thereafter, sin theta d theta will not come, sir.
Which one? Here, okay. UV method.
Sir,
Both.
you are differentiating with respect to theta, no, sir.
No, dt by dt. I had to find out this value. No, I had to find out this value. Minus g by 2, 2t dt into cot alpha. Solve for dt by d time by d theta and equate for 0. So for minimum, for t minimum, dt by d theta equals 0. Okay, now solve this equation and equate for 0. Then you'll get a that specific angle. So anybody value theta?
Sir, I put it in the chat, sir. Can you check it once?
chat. Okay, yeah. U cos theta tan alpha, it will be U tan theta.
Sir, there you should not be there.
This U should, okay, we'll do one thing. I'll write it here. Okay, no? Yeah, fine. Solve this. Somebody asked to scroll up, no? Okay, that one, somebody is asking there's a question, diagram. Okay, fine. So then looking at this, the question, the conditions given, we wrote these three equations. Huh? Okay, no, till here, fine. Then substituting 3 in 1 and 2 in 3. So we'll end up and finally equating for d theta dt by d theta equal to 0. Anybody value tan theta? I'll end up with this equation like this. Huh? Tan theta is equal to cot alpha. So therefore, what is theta? Theta should be equal to pi by 2 minus alpha. Substitute that value of theta there and get expression for T minimum. T minimum, I'll write the answer. You check later on. U minus root of GA sine 2 alpha check it once. Finally, you should end up with this much of condition. Just some the different way of this integration of dt by d theta equal to 0. And this will be our answer, final answer. So once you get time, no, you can calculate the speed. With what speed it will strike, you can calculate. Once you know time, you can get all other things. Okay, let me give one very good question. Let's see that how you work out with this. Take the one question. Two parallel straight lines are inclined to the horizontal at an angle alpha. A particle is read question. I'll not give diagram. You're supposed to get the diagram also. Read carefully. A particle is projected from a point midway between them so as to grace one of the lines and strike. This is striker and strike. And strikes the other at right angle. Show that if theta is angle of projection, if theta is the angle of projection with respect to either of lines, and alpha be the alpha is already given, no? Right. Then tan theta is equal to root of n minus 1 cot alpha. Find the value of n. Intentionally diagram not given because the student was supposed to assume the diagram also. Two parallel straight lines are inclined to horizontal at an angle alpha. Construct the diagram.
Sir, could you
No.
show once the previous answer, sir?
Okay, Maya.
Thank you, sir. Okay, so you can scroll down now.
Okay.
Thank you.
Okay, read. I'll display the question. Read carefully. Read carefully. If you can draw the diagram, no, so then you can manage. So some very important grace, so as to grace one of the line and strikes the other at right angle. I think this sentence is very important in constructing the diagram.
Sir, n is 2, sir.
We'll see. I'll solve it. I had to solve it.
Okay, sir.
completed. So let me try for the diagram. You try, meanwhile I'll draw the diagram. Okay, let the point of projection, let it be O. Angle of inclination. What is the angle of inclination? It is alpha. Then it is projected. It will graze one of the line. So let me call this the first line. This is the second line, no? Then what is it? It is projected in such a way that it will graze one and it will strike normally the other line. So I'll project it. Some rough diagram. Actually, we have to. Oh. It's a rough diagram. Just to make you understand, I'm giving. Because some students are, why can't it go like this? Huh? It is projected in such a way that it will graze. Huh? Okay, I'm making things clear. Let this be theta. So here it is grazing. Huh? I'll draw some thick line. Okay, fine. So somehow I made some adjustments like this. So it will graze and it will strike normally. You see that one. It has to strike normally. That also he has put a condition. It will strike the other line normally. So take this distance perpendicular. You can write anything. So this nothing is given, no? So we'll assume this to be A. So it will be P1 it will graze, at P2 it will strike normally. If you can get, he has not given intentionally diagram. So I think now you can manage here. So write equations of motion. So what is something that theta and alpha relationship is needed, that's all. So what all we assume, all other things are, has to be eliminated. What all we assumed A, we assumed U. So that should be eliminated. You write the equation and eliminate them. So that the relation between theta and alpha will come. So first, as it moves from O to P1. So let's resolve this velocity. It will be U sine theta. I'll resolve the velocity. So here it will be, I think once you get the diagram, no, so writing equations of motion next. So this will be U cos theta. U sine theta. What will happen to as it grazes here, no? It grazes. Here you put like this. Grazes, strikes normally. Fine. This one. So as it moves from O to P1, what will happen to U sine theta? Should decrease. So what shall I do with gravity? Gravity you have to resolve. You have to resolve gravity. So the gravity, if you resolve, no, will be G sine alpha, G cos alpha.
Sir, sir, just a small doubt, sir.
Yes.
You said that the projectile must graze one surface and it should hit the other surface perpendicularly, right?
Yeah.
But sir, doesn't the angle theta, that angle, won't it be
More than 90. Theta plus alpha more than 90, you mean to say?
it could be acute also, right, sir? I mean, theta
No.
plus alpha.
See, my dear, like, what is the, all of you, I think I made things clear. The diagram appears theta plus alpha. I'll put one simple condition. I think it's over, no? Okay, fine.
Okay, sir.
That's all. Because like, I had to draw a diagram very specifically. So I just already told you, like, it will not, the particle will not strike on the left side of O. It will go and strike at point P1 on. So like that, the theta and will be adjusted here. So that's what he's asking, theta plus alpha. But the diagram looks in other way. So why do it will move? Actually, it will move like this. No, you mean to say, will come like this. Will come like this. No. But so I'll just put condition theta plus alpha less than 90. I think problem solved. Okay, now let's write the equation. So what we should do now? We should get relation between theta and alpha. Okay, let's write from O to P1 as it moves from O to P1. I'll proceed with the mathematics now. From OP1, 0 square.
Isn't theta the angle of projection?
Yeah, with respect to incline.
So they didn't mention it is with respect to incline.
Question not there. Huh?
So they only told theta is the angle of projection.
Yeah, with respect to incline only, that one. Yeah. Theta with respect to horizontal become theta plus alpha. With respect to incline, theta.
Sir,
That
you
one.
told with respect to either of the lines.
It's there, no? Okay, let me check question. Let's see that. If theta is the angle of projection with respect to either of lines,
Okay,
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 fine.
sir.
Huh?
Okay.
Yeah. Okay, now let's write equation. Some mathematics will get into 0 square minus u sine theta whole square equal to 2 minus g sine alpha plus a. Try to see all these symbols. Why 0? Vertical component should be 0 because as it grazes means the velocity will become parallel to the line. So here it will
And
have
it is
velocity
G cos alpha, sir.
g cos alpha. Yeah. Yeah. 0 minus u sine theta whole square equal to 2 minus g cos alpha a, this one. So solving this, I'll get expression for a is equal to u square sine square theta by 2g cos alpha. Keep one equation in hand. Next, shall we take time taken to move from O to P2? From O to P2, we'll write one equation. Final velocity will be 0 is equal to from OP2 along the incline. It is. This was perpendicular to incline.
Sir,
Uh,
so will you answer the question, the figure, sir?
when it moves from O to P2, let me write along the incline. Along the incline, vertical the component of velocity parallel to incline will be 0 here. Initial velocity is how much? U cos theta, then g sine alpha. So shall we calculate the time taken to move from O to P? So t equals 0, I projected. After some time t, it will be available here. Shall we calculate this time t? Applying u plus at formula.
Sir? Sir, in the first equation, it should be v square minus u sin theta whole square.
So what is that, sir?
Which one, pa?
Sir,
Sir, here
2 minus g cos alpha.
and also it should be plus 2a, sir.
This equation v square minus u square equal to 2a is formula.
Yes, sir. You're taking
Sir,
it along
last.
OP perpendicular to the line, no, sir. Finally, the velocity is also perpendicular to the line. Instead, you take 0, sir.
OP1, no, OP1 from O to P1 I apply, not O to P2. I think just look at one's equation. It grazes, no, grazes means the velocity will be parallel to incline, no, parallel to line. No. Then I'm applying perpendicular to line. So what is the perpendicular component here? Will be 0. So 0 square. I wrote here in the bracket perpendicular to line. Okay. Just only see like u sine theta. What happened to perpendicular component will be 0, no, at point P1. Am I right?
Yes, sir. Understood.
Okay, got it. I think little bit some confusion. Huh? Shall I go down?
Yes, sir.
Yes, sir.
You may go down.
Okay, fine. Huh? Now we'll come for now. So this will be u cos theta minus g sine alpha into t. This is what? Parallel to the line. Any line it is, parallel to lines. Again, which line you'll ask it? Parallel to first line. Let me make things still more clear. Perpendicular to first line. This will be parallel to. Okay, now, is that okay? V equal to U plus AT formula. So when it strikes at point P2, so how the velocity will be perpendicular to second line. So therefore, what is the velocity along the second line will be 0. Okay, I got now one more equation. T equal to U cos theta by G sin alpha. Let me write from O to P2 perpendicular to line. Again, same equation from O to P2 perpendicular to lines. Perpendicular to second line. Let me write it perpendicular to. Okay, I'll show the diagram. See once. V square minus U square equal to 2as formula. So when it moves from O to P2, this is the initial, this is the final. No? So look at the displacement A. It is opposite to U sin theta. It is opposite to U sin theta. So therefore, so I'll write the equation V square minus U square equal to 2as formula. Or S equal to UT minus half it square, any of the formula. So this will be minus B, or say, sorry, minus A, no? Minus A is equal to U sin theta T minus U sin theta. As it moves from U sin theta, the displacement A is opposite to U sin theta, so therefore negative. What about G cos alpha? It is also opposite to U sin theta, so it will be negative. So therefore it will be minus A equal to U sin theta T minus G cos alpha T square by 2. Okay, substitute the value of T here. Okay, the value of T. So this we got. And the A also we assume, no, substitute the value of A. So call this equation 3. Put 1 and 2 in 3. Then eliminate the things. 1 9. Writing these equations is very important. So once okay, rest all solving now. So we have to solve this. Okay, let me substitute it. So this will be minus of sin square theta by 2g cos alpha equal to U sin theta. So U square gets eliminated, G get eliminated, then left over will be only theta and alpha. So we'll end up with tan theta equal to root 2 minus 1 cot alpha. Okay, it's all about now that applying that basic formula clearly. Is it okay? Theta plus alpha should be less than 90. No, then only it will strike that incline. Otherwise, it will move on to the left side. I think there's a general common sense, nothing to do. If I project like this, Why did it go here? It'll go like this, no? For it to go like this, what happened? The minimum. So if your velocity like this, it will come like this, no? The ball. This would be the trajectory. If your velocity is in this direction, how it is possible for trajectory to be like this? Okay. So therefore, the diagram appears theta plus alpha 90. That's why I wrote theta plus alpha. Let it be less than 90. The diagram appears theta plus alpha more than 90. So I made theta plus alpha. Let it be less than 90. So that you should not get confused.
So one scroll up, sir.
Yeah, let's scroll up. These are some generalized problems with the inclined projectile. So I think once you get the diagram, next what you have to do is like go for applying equations of motion along the incline, perpendicular to incline. That's all. Nothing is there. Complete it. I'll discuss some few more generalized cases are there.
Done, sir.
Okay, now so sometimes what happens, you'll be projecting the inclined plane. You are going to project with a speed u at an angle theta, such that it will go and strike normal. It can happen. Then you will ask you what are the conditions. Look at the point, where is the point of projection? The point of projection is not on the inclined plane, no, somewhere. Can we work out as it is? So what we should know, where it will strike the inclined plane. So this you call x1, this will be y, and this will be x, no? At t equals 0, you are projected. After some time, it will go and strike here. So what is a x is equal to u cos theta into t, y equal to u sin theta t minus gt square. He's telling himself it will strike normally. Since we know this angle, we know this angle, so we can bring that particular condition. It strikes normally, so you resolve velocity here. So here the two velocities will be there. This will be vx, this will be vy. If this is alpha, 90 minus alpha, this should be alpha, no? So here what is tan alpha, you can write it. Tan alpha as vx by vy. From tan alpha, what happened? I'll get expression for vx and vy. What is vx? Vx, we know u cos theta. See, I'm telling this one. So don't expect that inclined projectile problem will be like this. The point of projection can be somewhere on the ground also. If it strikes normally, if I put a condition, stone strikes normally at point P on an incline. This is a condition. So once it strikes normally means I get relation between Vx and Vy, and we know horizontal component of velocity should be constant. Is that okay? So I know Vx, I know alpha. Can I get Vy? Yes, I'll get Vy. So Vy equal to Vx by tan alpha or u cos theta by tan. U theta and alpha, you know, you'll get Vy. If you know Vy, you can calculate time. U sin theta minus gt. So you'll get the time. Once you know time, then you can get the value of x. Once you know x, then you can get the value of y. Once you know time, I think you can get the value of y. From y, you can get the x1. From x1, all other things. See, these are some best numericals that are available. So the point of projection need not be always on inclined plane. It can be somewhere. We discussed earlier, some it was at some, it will strike normally. I can project from the ground. So even if I give that, it will not strike normally, some angle also you can manage. Please do work out some numericals of these kind. So for exam, definitely the teacher who is going to set paper, no, you will try to see how student can analyze in different ways. I can also do like this. So just go for generalized thinking. What I suggest students is like rather than confining to some 10 or 15 problems, no. So instead of that, somebody mute it, mute it, please, mute it. Please mute it. Okay, now you see that one. The same problem can be asked in for you in several ways. No, I'll project here horizontally. Let this be alpha, this beta, so that it will strike the other inclined plane, making some angle. Called theta, where theta is definitely it should be greater than 90. Let's take something. I can do like this. No, earlier we did projected vertically. Let it be projected horizontally, or say like a alpha it is. Then he'll ask you all the conditions. So how much of distance it will move? I'll give this distance as a. To strike this, it will move a distance a, no? No, resolve the velocities. So one perpendicular. Able to manage. So you do one thing, rather than searching for questions, no? You take one inclined plane, ground, two inclined planes, inclined plane and ground. Analyze all the possible cases. If it moves like this, how, if I project like this, how do it move? If I project like this, how do it move? This is what needed for student. Not like don't go for searching questions. Already around 15 questions I discussed. Almost the major concepts I covered. The remaining thing, what happen, you analyze on your own. How do it will move? Fine, all of you. So this is about the inclined projectile, almost like a 3 classes I confined for this. Tomorrow we'll start the relative motion, relative accelerated. Some good number of numericals will be there in this one. First relative motion in 1 dimension, then we'll go for relative motion in 2 dimension. Okay, fine. This will be. So tomorrow I'll continue from here. Thank you all of you.
Thank you, sir.
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 Thank you, sir.